ADS-B, Automatic Dependent Surveillance Broadcast, ADS-B, permits an aircraft to determine its position via satellite navigation and periodically broadcast it, enabling it to be tracked. The information can be received by ATC ground stations as a replacement for secondary radar. It can also be received by other aircraft to provide situational awareness and allow self-separation. ADS-B is automatic in that it requires no pilot or external input. It is dependent in that it depends on data from the aircraft's navigation system. ADS-B is an element of the US Next Generation Air Transportation System, NextGen, and the Single European Sky ATM Research, SESAR. ADS-B equipment is currently mandatory in portions of Australian airspace. The United States requires some aircraft to be equipped by 2020, and the equipment will be mandatory for some aircraft in Europe from 2017. At least that's the plans. FANS and FANS 1. In 1983, ICAO established a special committee on the Future Air Navigation System, FANS, to develop the operational concepts for the future of air traffic management, ATM. The FANS report was published in 1988 and laid the basis for the industry's future strategy for ATM through digital communications, navigation and surveillance, using satellites and data links. Work then started on the development of the technical standards needed to realise the FANS concept. In the early 1990s, Boeing announced a first-generation FANS product known as FANS 1. This was based on automatic dependent surveillance and controller pilot data link communications, CPDLC, and implemented as a software package on the flight management computer of the Boeing 747-400. It used existing satellite-based ACARS communications via Inmarsat, Data 2, for the South Pacific Oceanic region. The deployment of FANS 1 was originally justified by improving route choice and thereby reducing fuel burn. FANS A. A similar product, FANS A, was later developed by Airbus for the A340 and A330. Boeing also extended the range of aircraft supported to include the Boeing 777 and 767. Together, the two products are collectively known as FANS 1A. The main industry standards describing the operation of the FANS 1A products are ARINC 622 and Euro CAE ED100 RTCA DO258. Both the Airbus 380 and Boeing 787 have FANS 1A capability. FANS 1A design is a range of future air navigation system products. FANS is an avionics system which provides direct data link communication between the pilot and the air traffic controller. The communications include air traffic control clearances, pilot requests, and position reporting. FANS 1 is Boeing's solution and FANS A is the Airbus solution. Both Boeing and Airbus continue to further develop their FANS implementations, Boeing on FANS 2 and Airbus on FANS B. ADS-B. Aircraft get their position from the GNSS satellites constellation. Then they simultaneously broadcast their position and other data to any aircraft or ground station equipped to receive it. Ground stations then transmit the aircraft's position to air traffic control. ADS-B out periodically broadcasts information about each aircraft, such as identification, current position, altitude and velocity through an onboard transmitter. ADS-B out provides air traffic controllers with real-time position information that is in most cases more accurate than the information available with current radar-based systems. With more accurate information, ATC will be able to position and separate aircraft with improved precision and timing. ADS-B in is the reception by aircraft of SIB and TSB data and other ADS-B data such as direct communication from nearby aircraft. The ground station broadcast data is typically only made available in the presence of an ADS-B out broadcasting aircraft, limiting the usefulness of purely ADS-B in devices. The system relies on two avionics components: a high-integrity GPS navigation source and a data link ADS-B unit. There are several types of certified ADS-B data links, but the most common ones operate at 1090 MHz, essentially a modified Mode S transponder, or at 978 MHz. The FAA would like to see aircraft that exclusively operate below 18,000 feet use the 978 MHz link, since this will help alleviate further congestion of the 1090 MHz frequency. To obtain ADS-B out capability at 1090 MHz, one can install a new transponder or modify an existing transponder if the manufacturer offers an ADS-B upgrade, plus install a certified GPS position source if one is not already present. The ADS is a FANS application performed automatically, without any crew action to define the set of data to downlink or the type of report contract. The different types of ADS contracts can be periodic, at periodic time intervals, on demand, when asked for by ATC, on event, whenever a specified event occurs. ADS-B versus ADS-A and ADS-C. There are two commonly recognised types of ADS for aircraft applications: ADS addressed, ADS-A, also known as ADS contract, ADS-C, and ADS broadcast, which is ADS-B. ADS-A is based on a negotiated one-to-one peer relationship between an aircraft providing ADS information and a ground facility requiring receipt of ADS messages. For example, ADS-A reports are employed in the Future Air Navigation System, using the Aircraft Communications Addressing and Reporting System as the communication protocol. During flight over areas without radar coverage, for example oceanic and polar, reports are periodically sent by an aircraft to the controlling air traffic region. The transmission delay caused by protocol or satellites is significant enough that significant aircraft separations are required. The cost of using the satellite channel leads to less frequent updates. Another drawback is that no other aircraft can benefit from the transmitted information, as aircars' information is not rebroadcast from ground facilities to other aircraft. ADS-B benefits. ADS-B provides many benefits to pilots and air traffic control that improve both the safety and efficiency of flight. In terms of traffic, a pilot is able to view traffic information about surrounding aircraft, including altitude, heading, speed, and distance to aircraft. In terms of weather, aircraft will be able to receive weather reports and weather radar through Flight Information Service Broadcast, FISB. In terms of flight information, Traffic Information Service Broadcast, TISB, transmits readable flight information such as temporary flight restrictions and NOTAMs to aircraft. Regarding the expense, ADS-B ground stations are significantly cheaper to install and operate compared to primary and secondary radar systems.